Hello, everyone. Welcome back to Things We Read This Week. I'm here again with Hunter Almgren. This is Jordan Nanos. We're talking about everything AI, data centers, technology, yada, yada. Um, this week, we're going to cover the build out in AI data centers because there's lots of updates there, an update on Intel's fab business. Um, We've got some other stuff about possibly consumer electronics getting released and, you know, privacy concerns with LinkedIn scraping data, things like that. But before we get into that, Hunter, how are you doing?
I'm doing well, man. Uh, I actually was down in Orlando this week for the last few days presenting all about AI. So big
It's
shocker, as I do every week. What am I doing?
tra
Giving another.
traveling the country talking about AI. Yeah. Where were you last week? NDA, NDA, NDA?
Yeah, I was gonna say where I was last week is an undisclosed location in South Texas, and I'm not allowed to say any more than that.
Awesome, man. Cool. So I'm gonna start with like something a little bit different. Going a bit of a diatribe here. So last week we talked about the kind of ante you need to pay to get into the frontier model game right now with AI. And I wanted to put some numbers behind it. So I did a armchair investment banking analysis here to just compare a little bit of what we're looking at with some of these companies because there were some updates on like how big these data centers are getting that we can kind of talk about in a minute. And I just wanted to make the point that like these tech companies are very different. And when you try to compete with them on a venture space with venture capital where you're looking for 10x return or something bigger, and they have such deep pockets, it's crazy. And especially if you are a typical Fortune 500 company, which I've got here on screen for the comparison, it's really crazy. So Google, Meta, Microsoft, Amazon, Apple, all well over $100 billion of revenue. Amazon at the top with 600 billion. Everybody but Amazon has a big profit margin, well over 20% for Google, Meta, Microsoft, and Apple. Free cash flow above $30 billion yearly free cash flow.
No big deal.
Google hits the top with $100 billion of cash, but the lowest one is Meta with 58 billion on hand. And the biggest amount of debt, Amazon, 157 billion, but Google, 28 billion, Meta, 38 billion. Like these companies have more cash than debt. Google and Meta do, right? Just if you look at that, Microsoft is close. If you compare that to like retail companies like Walmart, CVS, Costco, Home Depot, where they've got average revenues roughly the same, 300 something billion dollars, and average profit margin is 4%, so lower than Amazon. Free cash flow, $7.65 billion, nowhere close. They've got 9 billion, an average of 9 billion of cash on hand and 55 billion of debt. Go down to telecommunications companies, not as big on the revenue, even lower on the profit margin, or sorry, bigger on the profit margin, around 10%. Roughly the same on free cash flow, basically no cash on hand and lots of debt.
Hmm.
Similar story for automotive companies, Volkswagen, Toyota, Ford, Tesla. Like we're talking about negative free cash flow for a few of them. Um, some of them have tons of debt. Those auto loan programs are pretty crazy. And the only thing that actually looks even close to these tech companies that I could find, again, armchair is oil and gas, ExxonMobil, Shell, BP, Chevron. The super majors are in the hundreds of billions for revenue. They have relatively low profit margins, 10% or lower, but they have 22 billion in free cash flow, 25 billion in cash, and 51 billion in debt. The point is, like, in case you haven't realized, these tech companies have just a ridiculous amount of money on hand. And if you consider AI to be this existential threat to the business in Google's case, or a platform shift that Meta wants to capitalize on, or kind of the next generation that Microsoft doesn't want to miss out on after kind of missing mobile and mobile internet, it's hard to justify not spending 10% of that free cash flow 10% of that cash on hand, 20%, which is to the tune of, 10% of this would be an average of like $5 billion a year for each of these companies on building out data centers. We know they're going even bigger than that, but I don't look at this and say, wow, that's a significant change to their business if you do it in percentage terms of like somebody's going to invest a crazy amount of 25% of free cash flow and take on a little bit more debt because they want to build out some chips, right?
Mm-hmm.
So I wanted to start there as we get back to talking a little bit about these crazy data center AI buildouts and why, I don't know, NVIDIA might not be a bubble.
Yeah, I mean, maybe not. I think the other like thing that I see most often is a general acceptance that like a Home Depot is not going to go out and train a foundation model. Like they're never going to spend that amount of money. They're never going to, even if they have the data, right? Like even if they've been not just collecting, but sanitizing, prepping, labeling, everything else that goes into it before you can even get to that step.
Mhm.
As you've shown, they don't have the profit margins to do it. And so then the question is, well, now we have to take on more debt. I think, when you showed like the analysis of like the telcos, for example, right? Like they're very debt heavy and they always have been because it is not cheap to build all the infrastructure out for networks. Everybody's known that, right? And like that's sort of what like why I had such hope for Google Fiber and then just like municipal regulations and the traditional telcos stranglehold on the FCC at the time just absolutely killed the project, which is unfortunate. But like, they're that infrastructure is very costly to build out, and it's sort of a parallel to AI infrastructure. Like it's very costly to build out. So like you have a choice. Like, am I going to go $100 billion in debt just to say that I have a foundation model like Home Depot GPT?
Mhm.
Or am I just going to take a foundation model that somebody else, like a Google, Meta, whoever, who's actually got the profit margins to support ongoing development and just fine tune it to my needs? Right. I think that's where everybody's at. I think there's a general understanding, at least in the large enterprise space, of folks that I've talked to, that like, yeah, we're not going to do that. And you're going to have outliers, so like Bloomberg, for example, famously created Bloomberg GPT, right? Like that's what they're calling their foundation model that's based on, decades and decades of financial and market data that they've had. But I think that my question is like, would they do it all again? Like if there was a do-over, like would they actually spend that money? Now that's I only say that that's an outlier because companies like Bloomberg and Goldman and others, like they're in the business of printing money. Like that's what they do, right? So they could probably find it. Whereas somebody like a Walmart or a Home Depot, as technology forward as those companies are, still realize that this is probably more that they can chew, like biting off more than they can chew to like build a foundation model.
Well, okay, yeah. I mean, we can probably rat hole on this a little bit, but let me just make a point about Bloomberg GPT because you brought it up. Like, this is such an obvious example of why should an organization like Bloomberg train a model? So at the time,
Mm-hmm.
okay, they're going to add in their specific proprietary data into the pre-training, not
Yep.
fine-tuning, right? So, like, why would they train a foundation model that's custom? It had custom size. It had like some different at the time, I believe it was less clear what GPT-3, the architecture was. Um, anyway, look at this. The proprietary data that they contribute to this, that's not public, Bloomberg, is 5
Less
billion
than
tokens or
1%.
0.7% of the training. Yeah.
Less than 1%.
So much press on this model, right? And I think you can I think you can look at performance of just Llama 3 and say, scale is all you need on a lot of these finance related tasks because
Hmm.
it's going to pick up a lot of the stuff in pre-training as you just train it on more information. Um, Fine tuning and RAG may be a different story, but assuming that frontier models continue to get released, um, like you can download them. There, yeah, there's no way that people aren't going to start with the thing that Meta spent $100 million or $1 billion pre-training for the industry and
Yeah.
then released, right? So,
Yep. Well, and I don't
but
know that I don't. The other point too, though, is like I don't know that there's a lot of appetite anymore for owning your own floor tiles anyway, right? I mean, I see a lot of shift to like an Equinix or a DRT or a whatever, right? At least in the enterprise space, right? Because they're kind of like, I don't know, like, do we really want to be in the facilities game anymore?
yeah, that's certainly not a valuable piece of differentiation that Home Depot, to keep picking on them, would have over their competition selling lumber. Like,
Yeah, exactly. Like Home
um,
Depot versus Lowe's, like one guy owns their own data center, the other doesn't. Like, not really a competitive
it
differentiator
rarely shows up to a consumer. Yeah.
for sure.
Now, but so you made a point earlier about the build out of
Hmm.
telco networks, why they take on a lot of debt. It's it's interesting how similar people make all of these comparisons to the dot-com boom. It's like there's a bunch of data centers being built out with NVIDIA chips right now. Where do those chips sit? The two things in which having control over a data center would matter is latency, like how close are the user's devices to the model, um, and then control over their data.
Hmm.
So if Home Depot has data about their customers, or if they've got data about their individual products that's not public, that's going to inform some sort of response that's generated by a language model. Having full control over that is probably a good thing. The control that you have when using a Equinix or Digital Realty or some like data center provider is pretty much identical to if you're building an entire facility for yourself.
Yeah.
You don't have to be like the DOE. I love it when we look at the supercomputers um, like at Oak Ridge or Lawrence Livermore or Los Alamos or something, like Frontier, and they do the video of like building the supercomputer, and it starts with like dump trucks and concrete trucks laying the pad out so that you
Yep.
can roll in the system. It's not like there's floor tiles waiting for the big AI supercomputers, right?
No,
Um,
building it
so
from
the
scratch.
the people who are already in the building data center business, which is the technology companies and to a smaller extent the telco companies, they certainly have a opportunity, and the former Bitcoin mining companies,
Hmm.
they have an opportunity to host some GPUs because building a facility and running a facility is like a core competency of their business already.
Right.
Um, that's not quite the case for a bank or telco
A
or an
retailer
automotive
or
company,
yeah.
a typical Fortune 500.
Yep.
Um, okay, but you sent me something interesting about this data center build out. There, something last week and then another one this week. I want to pull those guys up. The first one that I liked was um, well, nuclear power's back, right? So
Yep.
Larry Ellison had some comments about nuclear power during an Oracle earnings call, I think. And then
Yeah.
there
Let
was
me
an
just
announcement today from Microsoft and Three Mile Island that's just like nuclear power's back, baby.
I know. And it's funny on one of the earlier episodes, it was talking about, Sam Altman and Oklo, his, SMR startup and how that could potentially change things if people kind of get over the hurdles, right, from like a regulatory perspective. But um, Oracle here is now talking about, hey, we're going to build this new data center, and because of the power requirements, we're going to go SMR, right? Like we're
Yeah.
going to build this out and power it using small modular reactors. Um, so now we're starting to see validation that we literally have to use nuclear power to power some of these buildouts, right? Um,
It
and
seems
we've
like it's
talked,
basically the only option. I
yeah, I
don't.
mean, I don't see another way.
So there is, but it's clearly the best option. So we see organizations who are building with solar, with wind, with
Hmm.
hydro, and with non-renewables, gas, oil, stuff like that, coal, right? Famously, like the U.S. East Ohio or whatever the AWS availability zones
Yeah,
or
US East 1, I think, is
U.S.
in
East one
Ohio.
is like coal fired, right?
Yeah,
And so you don't really want, if you're building fresh new data center, you don't really want it to be coal fired.
right.
But wind and solar doesn't work if a because a typical data center is online 100% of the time or close to
Yeah.
it. We're talking about four nines, five nines of availability, and you need base load power. So I don't know if people want to dig into this. I just read this book called The Grid by Gretchen Bakke, which is great. It's a little old now, but kind of covers all the challenges of America and Canada's grid. And the biggest thing is storage of power, right? So it's like if you're
Well,
using wind that comes and goes or solar that where the sun sets, you can't power a data center where you're training a model or trying to train a model 100% of the time.
yeah. I don't know. I mean, I feel like that, I don't know if you want to call it experiment, but like that whole thing that Tesla did some years back with Australia, where they provided that giant grid of Tesla power walls, essentially, like as a essentially a backup generator for their grid,
Yeah,
that had
batteries.
instantaneous failover. Yeah, batteries. Like that's one way to do it, right? Where like you combine wind and solar and you just build. But then the question is like, okay, how much physical real estate do I have to basically build a battery array the size of the data center that I just built to power this thing, right? And do I want to do that? The other piece of it too is I think it's the same problem that most people have on a inside the data center, like on a per rack level, right? You're constantly balancing density against power and cooling, right? And so this isn't really different. Like you're balancing power requirements versus density.
Yeah.
Like, yes, wind and solar are great, right? But let's think about everything that's involved in that, right? I mentioned battery arrays. There's other considerations to make. Nobody really wants to do a net new data center build out using coal. I feel like that would go against all of these companies like ESG goals. Um,
I'll just
so
buy enough carbon credits and then who
yeah,
cares?
exactly. Just swap carbon credits with the big financial firms doing trading, and you'll be good to go. Um, so what's the answer, right? Nuclear seems like a pretty clean option. Now,
So
what's
the
interesting about the announcement this morning
yeah,
isn't to me um, is not that, oh, Constellation Energy is going to sell nuclear power to Microsoft for AI data centers. That's not the interesting piece. You brought this up actually this morning. The interesting piece is the total contract value of this over the next 20 years and
mhm.
what implication that has, like, on, hey, maybe there is something to this nuclear thing and it could be very lucrative for the people who are getting involved.
And it should be, honestly.
Yeah.
I mean, if you have consistent baseload power to the tune of almost a gigawatt here for
Yeah.
Microsoft, like they're buying, which is just insane, right? They've got a contract for 880 megawatts over 20 years. Um, which is yeah, I mean that's that in and of itself, just the fact that they're committing that much money to a single power source is crazy.
Hmm.
Effectively $16 billion, $800 million per year for 20 years, right?
Yep.
Um, it's yeah, and the thing I was reading was from this guy Mark Nelson on Twitter was saying uh, they're paying for a 40-year-old reactor just to get to age 60. So,
Yeah.
it's crazy, but the this is the consistent theme in AI is that this is the worst it'll ever be, right? So if you think this is a bubble, then you believe this power plant is going to be shut off, what, 20 years from now? Because they're committing to 20 years,
Right.
which is crazy. But um, they're not just gonna walk away from that commitment 3 years from now and be like, no, no, guys, shut down the nuclear power. We're not going to use it, right? Um, but the other thing is that like conceptually it expands from here, right?
Hmm.
It gets bigger. They restart more power plants. They build new power plants. And so the guy on Twitter made the point. We now have a market for new build. Like this
Yeah.
sets precedent
And
for
this
what a deal can
this
be done at for future nuclear power plant buildouts.
and this was always the problem. Well, okay, outside of regulatory and just general public sentiment on nuclear power, take all that off the table. I think the biggest issue with nuclear power historically has been the fact that every single plant that's been built in the US has been 5 years and billions of dollars over budget, right? Like
Yeah.
there's never one that's been built, at least that I can find, that's been built on time to budget. They're very capital intensive to build, right? And rightfully so, given what you're dealing with. Um, this deal, I think, my opinion, starts paving the way, as you mentioned, for more build outs, not just restarting old nuclear reactors, but also building new ones on modern technology that may be smaller and more efficient, because there's actual ROI that can be demonstrated here.
No, I think it even goes further than that. I think the thing I'm most excited about is the concept that a Microsoft, an Amazon, a Facebook, a Google is actually going to be the operator or the counterparty holding this
Hmm.
this organization, you know, Oracle in their case with the three small modular ones.
Yeah.
If you have one single customer that's like the most demanding and biggest company and in many ways the most um, efficient and competent company in the world, you're going to be pretty good at meeting their needs.
Yeah.
And that's a little bit of a different category than a monopolistic utility expanding their total power generation by 3% with a government grant. In
Hmm.
which case do you think it's more likely for something to go over budget and over timeline? When Microsoft is chucking 800 million bucks a year at you, or when a, you know, utility that covers the entire Pacific Northwest is like, I'm going to add a bit of nuclear power to the grid. It's like, obviously the second one is
Yeah.
going to be a little bit lower quality. So the only thing that I think stands in the way here is regulatory concerns
Hmm.
and, specifically monopolistic practices where it's like, I, as a consumer who wants to turn on my air conditioning, probably don't want to be fighting with Microsoft on the grid for who can pay the most for the next kilowatt.
Right.
So it seems that this is no longer a massive grid where everybody kind of comes to the table and it's an even playing field. And now there's going to be these little microgrids that
Hmm.
power a nuclear reactor right next to a data center, three
Yeah.
small modulars right next to a couple few data centers. And the the shift away from government and toward private industry is probably good for the near term build out, especially because they're like going to build the power that they need to power the chips that they're building. But
They're
the
bankrolling the infrastructure, but I see what you're saying, right? I mean, it's a little bit of a slippery slope where, like, now what? Meta's our power company. Like, we have to pay Microsoft to get 20 kilowatts a month power.
well, we kind of worship at the altar of innovation with these companies and the ethos of move fast and break things, and that's not what I
Hmm.
want from my power company. So they've got to
Right.
change to behaving more like monopolistic, entrenched, you know, uh, people with employing more, um,
Lobbyists than engineers.
employing more lobbyists than engineers. Exactly. Yeah, which is fine if right if Microsoft's already headed that direction, Google sure follow and close behind.
Hmm.
Um, I guess I'm more okay with that, and then getting frustrated with my lobbyists not writing good code for my Facebook app that seems pretty much done. Like how many more features are we going to add here, right? Like the biggest companies in the world should look more like, you know, the GE or the Boeing of years past than um, the Google of 2010 or something like that, right?
Hmm.
The Nvidia of today. Like, uh, yeah, maybe a little bit more collaboration between the government and the biggest companies in the world is a good thing as we
Well,
build out these massive things.
and how does this new, I guess I have another question, right? Like, how does this new model of having these microgrids that power all these AI workloads affect, and I brought this up on a previous episode, right? How does this affect the last mile carriers, right? Like, I don't hand a check every month to Constellation Energy for my power. I hand it to an intermediary who then charges me a service fee on top of what Constellation is providing them for my power. So, what does this do to them as they continue to get cut out over and over and over again? Is now my last mile carrier that services my region going to be the one that's competing with the Microsoft or the Amazon or whatever for power? And then what strain does that put on their ability to supply power to the last mile?
You're gonna Google Pay your Google Sense for your Google Fiber and your Google Power. It's
To
a
log
brave new
on to my
world.
Gmail and Google Chrome and uh, talk to
Yeah, I
my
don't
Google
know.
Home.
I don't know. It's becoming harder and harder to like I don't know how to think about exponentials, right? So
Yeah.
this is the biggest nuclear deal ever. And what's it going to look like in 3 years, right?
Hmm.
This was the GPT-3. It's the biggest model ever. And now I can run something higher quality on my phone, like a year and
Yep.
a half later. So,
Yeah.
like, okay. Um, yeah, we'll see, man. The let's shift gears a little bit uh to the other kind of let me try and segue this one. So if we're going to power AI, we need power, we need data, which we talked a little bit about with Bloomberg GPT. We're also going to need some chips. So we're back to talking about chips.
We are gonna need some chips. So there was, uh, I think last week there was rumors swirling that Intel was going to get out of the fab business, um, or a couple weeks ago maybe, and as basically as a way to do some cost optimization, right, to get them out of the rut that they're in. We've covered this on previous episodes. Intel, their fab business called Foundry, has been bleeding cash since inception. It's very expensive, even despite government grants, right? You could equate that to anything we've talked about on this episode of how expensive it is to build this type of infrastructure. They finally confirmed it that they are getting rid of, they are going to
Yeah.
spin out their chip fab business. What's interesting and quite hilarious about this is this second part of the headline. AWS signs up for custom AI chips from Intel's fab. So not only is Intel spinning out their fab business, they're also going to start making ARM chips like Graviton for AWS. Like, so not even Intel chips anymore. Like, they're like, we will take anybody's chip business.
Yeah, which conceptually is the point of a fab business, right?
Of
The
course.
fabless companies come to you and you only create chips, but it is hilarious that the like cornerstone customer is somebody they've got a lukewarm relationship with right now.
Right. Somebody that they're actively trying to compete against, basically, if you think about it that way. Because I mean, all AWS is doing this, Microsoft is doing this, right, with Maya, and I forget the name of the other chip, but like they're all kind of wanting to go towards this custom silicon, purpose-built silicon based on ARM, and stop their reliance on x86, but more specifically Intel, right? Because that's traditionally been, I remember 10 years ago an Intel person saying like, oh yeah, AWS, like they literally buy Xeons by the pallet, right? I mean,
Mhm.
they're like, we're just semi trucks and semi trucks of these things rolling in. Um, there seems to be a bit of an appetite to get away from that, right? And diversify their um, choices. And if they're doing custom silicon at scale, right, that starts to basically eliminate overhead in the instances that they provide, which lowers the cost per instance in AWS. Um,
Yeah,
Theoretically,
well,
right? I say theoretically because you think AWS is going to lower their prices because of this. Probably not, but they are at least going to continue to with their plans to move more and more things to their own silicon.
yeah, and I think um so the big news is that they're confirming the spin out of the
Hmm.
Foundry business, which
Yep.
you mentioned this on a previous episode. AMD already did with Global Foundries, and it's worked out well for the fabless AMD business.
Hmm.
But I wouldn't say it's worked out swimmingly for Global Foundries, right?
True. Yeah.
Um, so I don't know if it's a like that was like 2008 or something. So I don't know if this is a perfect mirror.
2008, 2009.
Yeah, it's a different time now, like
Right.
more than 15 years later. So um, we'll see if there's such a big appetite for another foundry business now. Um, there's certainly an appetite for fabless chip businesses, right? Um, AWS is building their own. Um, Google builds the TPU. There's all sorts of fabless like design firms that will partner with
Hmm.
these companies to design their own silicon. And when you think about like the TikTok that Intel famously always did with the development of the chips, I
Yep.
mean, that's kind of happening with the industry where it's like there's a big wide diversity of stuff, and then it all consolidates to x86, right? IBM had their chips, and HP had their chips, and Intel had their chips, and then it's like everybody kind of comes to x86, and then there's one, maybe two vendors of it for a little while. And now we've got x86, we've got ARM, we've got RISC-V across consumer, mobile, gaming, all sorts of
Hmm.
data center stuff, plus all the AI accelerators where it splits between training and inference. And NVIDIA is the biggest chip company in the world without owning a fab. It's like 2024 is very different than 2008 timeframe when AMD spun out its fab business. So
It is.
I'm I'm not sure. The only thing that I would point out though is that like TSMC is like actively building its Arizona project. They are in line for $6.6 billion of grant money for the CHIPS Act and a $5 billion loan. They are at this point with no money dispersed to them yet. So Intel Foundry, whatever it's going to be called, got some catching up to do, guys.
Yeah, for sure. What's also going to be interesting to see is I think this is going to be a case for or against vertical integration, right? And how that plays out long term. Because think
Yeah.
about it, right? Like, you just said it, right? NVIDIA doesn't own a fab, right? AMD doesn't own a fab. Intel does. Well, at least until next year when it's no longer owned by them. Um, it's
Samsung, there's
yeah,
companies that own fabs and execute well. Sure.
absolutely, 100%. So like you see this like fab or no fab, vertical integration or no vertical integration. Like it'll be really interesting to see how that plays out long term.
Yeah, I don't know if that's the way I think about it. Like, it will be interesting to see, but I don't think it's necessarily the business strategy of vertical integration or not vertical integration is the actual thing that points to success or not success. It's like quality of execution.
Hmm.
Like, I think you can build a good business with vertical integration and you can build one without it. And if you're NVIDIA, you just execute perfectly for years and years, and then you're the most valuable company in the world for a short period of time without a significant amount of vertical integration. Like, they're trying to do it with the network, they're trying to do it with the software, but people just buy the chips for
Right.
like 87% margin, right?
Hmm.
And somebody else makes the chips and somebody else mostly designs the software. It's like PyTorch on an H100 built by TSMC is the most valuable company in the world, and Facebook gets nothing and TSMC gets a little bit, and NVIDIA gets basically all the margin, right?
Hmm.
Um, okay, what's the comparison for the other guys? I don't know, like vertical integration into the power thing that we were talking about before, into the data center business. Is that gonna, if the flops from my um, model response come from a Bitcoin miner running a GPU with somebody else's software and served by, Mistral as a company that just builds models versus vertically integrated Facebook, where it's like the flops come from a Facebook data center powered by a Facebook small modular reactor on a Facebook chip with a Facebook front end of Meta.
Yeah.
Like, what's the more valuable business? I don't know if it's vertical integration that's good or not. It's probably just going to be down to the execution of like Facebook, while vertically integrating, is their model better than Mistral's?
Yeah.
And that's the one that people are going to use. And I don't know.
Hmm.
I don't know if it's obvious that like, well, it seems to me actually that in this case, the vertically integrated Facebook, to the points earlier, is more well set up to execute than Mistral burning venture capital money and not having. Let me go back to the spreadsheet. Not having $149 billion at 34% profit margin with 32 billion of free cash flow, 58 billion in cash, and 38 billion in debt. Like, what are those numbers, dude? Mark could go out and just be like, yeah, I'm going to spend $10 billion on chips next year.
Hmm.
And that would cut his free cash flow by 30%. Or he could increase his debt by 10 billion and he still has more cash on hand. Like, come on, man.
I know.
Whatever. Okay. Um, we got back to being investment bankers for a second there. So one thing you sent me just on the chips thing before we get off it is, okay, let's call it vertical integration. Um, IBM.
Oh man.
Uh,
So yeah, I read this article that was basically mainframes are learning AI tricks. And I'm like, I'm sorry, what? Say that I had to reread the title of this like 3 times for it to like really sink in that like they're actually saying that people are doing AI workloads on mainframes now. And I I'm honestly like, why? Like is this IBM's like last ditch effort to bleed more money out of mainframe customers? Like, hey, we're gonna move to x86 because we have all these AI workloads. Oh no, 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 no. Mainframe does AI. Mainframe does AI. Hold on. Like what is this? Why? Why would you run a modern workload on mainframe? Like it makes no sense to me.
yeah, well, so my take on this when I saw this was that they've got Watson, which nobody knew what it was, and then I saw something Watson X, and so now they've got Watson Z or Watson Z with the mainframe brand.
Hmm. Yeah,
We're gonna play Jeopardy with the mainframes, I think.
this is unreal. It's like I
So
don't.
yeah, I'll try to be charitable. I get something of like we talked about it earlier, the quality of your artificial intelligence is dependent on the quality of your data. There's a lot of interesting data in mainframes. I could imagine a model
For sure.
accessing data that a mainframe runs. I can't imagine putting GPUs in a mainframe and running a model in a mainframe. But yeah, whatever. Um, the the general feeling of like um, people saying things with a straight face because their compensation plan says so is kind of crazy right now. Like, you
Yeah.
know, um, I'll run AI on mainframes when pigs can fly, and now everybody's trying to put strap rockets to pigs or something. So
Yeah, and it's funny because like part of me just looks at this and goes, I mean, this is kind of one of those things that like I open up almost every presentation with, which is if you say AI 10 times on your earnings call, your stock goes up, right? I mean, we're still in that period of time today. So like is this IBM saying AI enough times that people associate their long-standing mainframe business, which is probably keeping IBM afloat, to AI, and then they go, "Oh, IBM's AI company, right? They're selling mainframe AI stuff." Kind of like, some of the financial trickery that's been exposed by a lot of tech companies very recently about them counting revenue as AI revenue, even though they're basically making a very broad categorization of their revenue just to say that they're an AI forward company. Like, is this that? Right? Like, are they just trying to recategorize mainframe business as AI business so that people don't look at them as, where things go to die, which is kind of what is the current state? No, I don't know. Right? Like,
yeah,
um, that's a
yeah,
valid question that I have.
yeah. Look, okay, let me shift to something that I saw. People were comparing. So OpenAI released uh what did they call the model? O1, right?
Hmm.
The new like self-improvement thing. They think they've unlocked this flywheel. They called it O1 preview. And somebody was doing a comparison between um its multiplication capabilities compared to GPT-4o, right? And O1 preview does a lot better at math, right? And it was something like uh, O1 preview can multiply, numbers up to 9 digits or something, and 4.0 could only do it up to 4 digits.
Hmm.
And I saw this comment from somebody saying, like, well, the funny thing is that with all of these models, they actually have to do trillions of correct multiplications just to get that one multiplication wrong. like like if you look at what's happening on the chip, there's trillions of every time there's one forward pass in the model, there's literally for a trillion parameter model, there's more than a trillion uh, correct multiplications and correct additions being done for this, AI to actually to work. And so
Hmm.
there seems to be a difference between the practicality of what somebody's going to do with AI in their business and what people want to like cheer for and be like, this is the pushing the frontier of research and bring us toward AGI or super intelligence or
Yeah.
consciousness upload to the software, whatever you want to do. In an interesting way, I think that if IBM is truly interested in connecting data from mainframes into an experience driven by a language model, where somebody can ask a question in natural language, it can convert it to a SQL query, it can run it on some database, it can access the data in real time from a mainframe, it's all secure. I mean, conceptually, that's like a really good and interesting thing. I just don't read
Sure.
this article and come away from it being like, IBM is definitely like going to do that and be focused on customer outcomes with the uh, data that's in their mainframe business. It seems
Hmm.
more like lip service, so
That's
not the most
exactly
positive on it.
yeah, that's exactly the way that I took it. And you bring up a lot of valid use cases, right? I mean, um, these are all things that they could be doing to put some meat behind this statement. But that article was basically a lot of fluff. Like, how many times can I tie the term artificial intelligence to the term mainframe?
Yeah, yeah. Which I mean, working with people in marketing or in PR, um, there's a lot of search engine optimization that happens on some of these blog posts where you try and point things to certain keywords.
Uh-huh.
Hi, I'd like to write a blog post about these 4 keywords that seem popular right now, like the sort of backwards reverse engineering of a blog post that,
Yep.
hey, a language model could probably write a great one for you with that input, that prompt. Oh man. Okay, I think it's time to move to wrap here today. Just
Yeah.
covered a lot of ground, a lot of big stuff. Uh, I don't know. Looking forward to more, man.
Yeah, so am I. I think the last thing that in today's example of, oh shit, change the terms of service before we get sued. LinkedIn was recently um, caught scraping user data for training before they updated their terms of service. So meaning they started the work and then probably somebody in legal said, yeah, we need to basically put some new terminology around that and throw an opt-out clause in there. Because I don't need Gavin Newsom coming after me for, California data privacy law violations. I
Yeah.
just thought it was interesting because, this incident is what a lot of Fortune 500 companies are dealing with right now, where they're innovating at a rapid pace in the AI space, but then it gets to compliance or legal or some other regulatory organization within the company, and they're like, yeah, no, like not okay, right? And this I think is, and I talk about this quite a bit of like, this is kind of to a degree, it's two things. It's slowing down the pace of innovation to a degree, right? But it's also exposing all of the unknowns in how we regulate this stuff and how we give people the choice to opt in or opt out, and everyone seems to be kind of taking a different approach and figuring it out as you go. So I think that was kind of the two takeaways that I got from this news article outside of, my LinkedIn profile is now part of some AI model, if it wasn't already, right? Which it probably was from 19 other companies scraping it, but you know,
Yeah, like I get it. You probably want the feeling of
the illusion
opting
of
in or
control.
opting out. Exactly.
Yeah,
Yeah. But that's really what it is. And I don't know. I don't go to bed at night worried about who's using the one picture of me that's on LinkedIn. And I
me
think a lot
neither.
of people who truly do worry about that at night don't put
It,
pictures of themselves on the internet and make that
they
choice. So
probably don't have a LinkedIn, or if they do, they don't have a picture.
it's not required, guys.
No, it really
It's
isn't, right?
it's not required. This is voluntary. Um,
Well, it goes
but
back to the
yeah,
old saying, like, if the service is free, you're the product.
right, right.
And that's
Yeah, yeah,
that's it.
yeah, yeah. Yeah, yeah, the idealism largely about like regulation in this space is, I think, misguided. It's hard to forecast what this stuff's going to look like in a few months, in a few years, and I just always go back to the export controls on the chips and stuff. It's like this regulation is put down with this point in time.
Hmm.
They're like, you cannot export chips over this many teraflops to China or
Yeah,
to Vietnam or something.
the no countries.
You can't you can't train a model more than whatever it is, 10 to the 28 exaflops, or like they talk to some researcher about how big are these models right now, and then they put it in the language of the regulation. It's like, okay, there's relentless progress on the chips and the models and the data. Come back in 2 years, this regulation's out of date. But that's
Yep.
yeah. So either refactor the regulatory environment to accommodate for the speed at which this stuff's moving, or use a different approach.
Yeah. Very true.
I don't know.
All right.
Hey, this was fun, man. Talk to you
Yes, indeed.
again next week.
Sounds good. Thanks, everyone.